Hello, this is the Exhausted Programmer. My name is Alexander, and today we are talking about algorithms. What is an algorithm? It's a series of steps that takes something and turns it into something else. That sounds kind of vague. Oxford Dictionary goes on to describe it with terms like computation and problem solving. I've seen it be used to describe things like tying shoes and cooking a recipe, but math is more in line with computers, and that is what we tend to focus on here. So let's look at a mathematical algorithm. In school at some point, many of us were asked to find the largest number that could be used to divide two other numbers. This is called the greatest common divisor, and it can be very useful for many things. For today, we just want to find that value. If I was doing this myself, I would turn each number into a prime number that, when multiplied, gives us that original number. Then I would find the prime listed in both places. I would then multiply those numbers to find the greatest common divisor, and that would be the answer. This works for me, but for a computer, finding primes can take a bit more time, especially the larger the number. Instead, Euclid gave us a simple but effective way of finding the greatest common divisor. First, we see if the two numbers are equal. If they are, then that number is the greatest common divisor. If not, we take the larger number and replace it with the difference between it and the smaller number, and then we repeat. That is, we check to see if they're equal, and if they are, that's the greatest common divisor of our original two numbers. If not, we subtract and replace, and so on. Why this works is beyond the scope of this video, but it does. Also not in the scope of this video is things like computational complexity, but I do want to point out that sometimes there are more than one algorithm that can successfully give us our answer, and sometimes the runtime of one of these algorithms is fundamentally better than the other. Let's look at one more algorithm for finding the greatest common divisor. If you didn't see the video on integer math, the percentage sign here is like dividing, but it gives us only the remainder of that division. Here we continue until one number is 0, and the other number would be our greatest common divisor. We can compare the two using two numbers that are significantly different. For the first algorithm, we would subtract 1 from 1 billion, and then we would have to do that about 1 billion more times before we finally get 1 as our common divisor. The other algorithm would run only once. This isn't an actual analysis of the two solutions, but it does show that there's a significant performance difference between the two. And even if you think to check to see if one of the two numbers provided is 1, what if we use 1 billion and then 2, or 1 billion and 3? How many small numbers are you going to check before the simple act of checking for small numbers becomes more work than it's saving you? Algorithms are just repeatable steps that take some input and give us some desired output. Don't get too hung up on the idea that it needs to be math and arithmetic. These systems can be used for things like cleaning up images and sound, adding color to black and white images, stability of shaky videos. All sorts of things are done by algorithms. Thank you for watching.